Everybody here on the call today for the Lunch and Learn series for Lawn and Garden. Today we're going to be kicking off with Soil Basics, but first a few housekeeping announcements. I'm sure you're all familiar with your facilities by now. This is a typical extension talk, so if you in your facility, you should know where the bathrooms are, and also if you have a food pantry, snacks are on you today. So if you'd like to go and get some snacks from your pantry, and then also there are some beverages in your fridges, I hope. So feel free to join and grab a snack, and we'll spend some time here today. And we'll talk about some soils. So I am the one of the ANR educators in Tipton County. I have to keep correcting myself. Amanda Baird is our other ANR educator. I'm also joined today by Krista Poland from Cass County. Today we're going to be talking about soil basics. Some of you, this might be the first time you've seen a topic like this, and I'm going to warn you ahead of time. It is kind of a technical talk, but we're also going to be giving you some of the practical hands-on applications that you could be doing to learn about the material. Soils is not a very easy topic to discuss over a virtual setting, but I will say that you could spend several days learning about soils and not fully understand everything that goes on with it. But we're going to go ahead and start going through the PowerPoint here and talk to you guys a little bit about what is comprised of soil. So we'll go through soil components, soil formation, texture, structure, color, and drainage, and then Amanda is going to take over with the web soil survey and talk about some of the more chemical properties of soil and some of the things that we should be considering when we are planting our gardens. So we'll go ahead and get jumped into the next slide here. So what is soil? Well, I come from a soil science background. I taught a class over at Purdue, and it really kind of gets under my skin when people call it dirt. Dirt is what you track in on your boots from working out in the yard or in the garden, or what you get underneath your fingernails. So really what soil is, it's a living, comprehensive subject that's made of rocks, minerals, organic matter, organisms, air, and water. So if you look at the little demographic here on the graphic here on the left side of the chart here, you can see that roughly about 25% of the soil is made up of water, and 25% is made of air. And now that really kind of depends on if you have additional rainfall that comes in and the soil gets saturated. So we like to call that left half of that circle there the pore space. It's that space that's in between any of the organic matter or any of the solid particles that are in the soil. Now the next part that I really want to talk about are the soil particles. And the organic matter. This is in the solids. So these are your sand, silts, clays, any minerals that are left over, rocks, anything like that goes into that. But then when you start talking about organic matter is that really that material that has decomposed over time. So you've got components for that living organism. So you'll notice in that image here on the right-hand side, you've got a nice earthworm that's building a channel or a burrow down through the soil, so you can see that in that image. Also fresh residues. Any plants that have died recently, obviously a lot of our plants, especially our annual plants, don't overwinter. So those decompose, especially with grasses. Those all go dormant over the winter time, and so those can add to residues of the soil, and then organisms go in and decompose those. And decompose those into organic matter. So most mineral soils, if you look out, if you're not near a bog or any of the other types of locations, most of our soils are mineral soils. And they're comprised of about 1 to 5% organic matter. If you start getting into organic soils, up where bogs are located, or if they drained marshlands or anything like that, you can get anywhere for 30% organic matter or more. So really what organic matter does is it kind of acts like a sponge and helps you maintain soil nutrients. And so that just kind of helps promote like healthy organisms within the soil and help provide those essential nutrients to your plants that you need to grow. So we'll go ahead and step forward here. We'll talk a little bit about soil formation and different forming factors. This is basically how soils form over time. And you'll see time is the last thing that we have mentioned here on this slide. But it's basically the accumulated effect of all the other aspects that are above. So if you're you look at your climate, for instance, in Indiana, we see pretty much all the different aspects of weather and climate. So it gets warm in the summer, cool in the winter, and sometimes very cold in the winter. But if you go north, the temperatures oftentimes are not quite warm enough for organisms to get in and start decomposing organic matter. So you could see up in northern latitudes that you would start seeing potential for higher organic matter content. And then vice versa, if you start heading south, especially down near the equator, a lot of those soils are extremely weathered, a process that we call, we'll learn about that here in a second. But the organisms have gone through, decomposed everything, and it's hard to see that soil have a whole lot of organic matter, and they're really old soils. Also, wet versus dry. So if you have a wetter climate, a lot of times you could see some of the organic matter getting washed down through the soil profile, and it helps with increasing soil horizons. We'll see that on the next slide. Drier climates, sometimes it may be a little bit more difficult to do. Organisms also play a vital role in that. So their life cycles, so the organisms' life cycles themselves, I mean, they grow up and then they also die, and then they contribute to organic matter buildup in the soil. Also, nutrient cycles play a big deal in that. So knowing what type of nutrients become available for plant uptake. A lot of these organisms, animals, ground squirrels, any animal that can burrow through the soil or have earthworm channels, they're also involved with soil mixing. So they like to mix up the soil, and so you can start bringing nutrients and stuff down to the profile, or you can also cycle nutrients that are lower in the profile and bring those back up to the top. So that's something that can happen with those. Looking at topography, looking at soil profiles on slopes are going to look a lot different from the top of the hill or the bottom of the hill. So that's something to take a look at. Sometimes, most of the time, organic matter can wash off from top of hills and move its down way into a depression. And so you'll get a soil profile that would look different compared to the one that would be up at the top of the hill. Also, parent material. And parent material is basically what that soil was made from. So if you go down in southern Indiana, a lot of those are made from sandstone, any of those types of stones, limestone, a lot of those different things, and they weather over time and stuff like that. But if you look up in northern Indiana, central Indiana, we were covered by a glacier over several years and several times. And what that did, that came through and started grinding up the soil profile. And so we get a parent material of like glacial till or glacial outwash. But that's for a more in-depth talk on soil science. All right, Amanda, let's go ahead and move on to the next slide here. So here's what the whole process really kind of looks like. So in that left side of the graph there, you'll see that soils begin to form. So you'll see rainfall hitting the surface and then start to penetrate into the soil percolating into the soil. So you can see that. And then the step 2, organisms start to develop. So you get plant material, those die, and the organisms start to decompose that plant material. And so the organic matter really starts to increase from that. Again, water starts moving through the soil profile and still try to start breaking up some of those soil, that parent material that's through there. And then organisms can go through and start breaking that down as well. Frost and freeze events can also help break up that cycling or that the structure there, and that's part of how some of that weathering has happened across in the past. When you start getting to step 3, when you start seeing horizons starting to form, especially in this image, you can start seeing that we've had enough time where we've had plants cycling and growing and dying and decomposing. You start getting a horizon called the A horizon. And what this basically does is that's where your topsoil is located. It's where a lot of our plants are pulling their nutrients from. And then you also see down further in the soil horizon, you see that C horizon, which is your parent material. And so you can see how over time that's kind of progressed. And then when you start getting to the step 4, that well-developed soil, you've got your organic matter that's built up, your mineral particles, and then you've also got your parent material. And you start getting different horizons. You got your B horizon, where you start getting the accumulation of clay material, irons, and other types of materials that go in that. So primarily that topsoil, that A horizon, is going to be where you have your a lot of your plant nutrients that they like to pull from. So let's go ahead and move on to the next slide here, Amanda. So we see here the horizons, and this is just kind of, taking that last image and looking at the actual profile. So you can see some soils, not every soil has an O horizon, which is an organic horizon. That would be part of the topsoil. That's anywhere from your 0 to 2 inches, highly decomposed plant material, and then you start getting down into your A horizon. And depending upon if your soil formed underneath of a forest or a grassland, your A horizon could be deeper or shallower. It just depends on the location that you are. Then you look down here in your B horizon, you start getting that subsoil into the subsoil, and then down into the C horizon for your parent material. So that's something that we can see with those horizons there. So when we talk about soil texture, all we're really talking about is basically the size of the different particles that make up that individual soil. We like to use the term sand, silt, and clay, and you can see here on this slide, the sand is the largest particle, the middle-sized particle would be your silt, and then the clay would be your smallest. And let's go ahead and move to the size comparison. Let's just pretend for a second here. We've got a bowling ball here on the left-hand side. If we were to take a microscope or a magnifying glass and try to look at these individual particles, and if we tried to relate to like their actual particle densities, we would almost equate it to a sand particle being the size of a bowling ball. And then a silt particle would be the size of a golf ball. And then when we look at clay content, or the actual size of clay, it'd just be the tiny little tip of that push pin that you would see there. So that you can notice that there's a huge size difference between all these different particles, and there's a lot of different properties that get affected because of that. So let's go ahead and move on to the next slide here. It's really hard to find a pure sand, a pure silt, and pure clay in nature. So a lot of the soils throughout the United States and our areas are a combination of 3 different soil types. So you've got a percent sand, a percent silt, and a percent clay. You can see the percent sand is down on the bottom of the triangle, and those arrows, they actually go up and to the left. So the arrow pattern there you can see on that slide. So if I had a soil that had 50% sand, I'd follow up on the line there. So I automatically know that I'm somewhere down here on that sandy side of the triangle. And then if I had a soil with 30% silt and 20% clay, I would be right there in a loam category. So that's something that you could see. Just utilize that triangle to determine that. Now you can do it. You can texture by feel. You can also do a more in-depth scientific way called the hydrometer method. Or you could just cheat and utilize the web soil survey that Amanda is going to be showing you here in a few slides. So we'll go ahead and move on. So the perfect soil for gardening or agriculture, like we like to talk about, we like to see about 15% sand, 15% silt, and about 15% clay. And then the rest of it would be 5% organic matter and about 50% of pore space. So that, if you remember back, that pore space was the space in between different particles that you had there. And that's just something that we would like to see with that perfect soil. Next slide here, Amanda. So what does soil texture mean for you? And so if you have, what it really relates to is water movement, nutrient retention, and different soil textures and how those impact those principles there. A sandier soil is going to have very little water holding capacity. So you're going to be more prone to droughts and the water is going to move through it a lot quicker. So you're going to have to water more frequently. If you look at clay soils, they have higher, and silt loams, they have higher water holding capacity, and the water takes a little bit longer to move through it. So the soil is able to hold on to water a little bit better. And so therefore you're not as prone to drought. If you look at nutrient retention, you've got clay soils, they hold nutrients better than sandier soils, also relating back to, and we aren't going to really get into cation exchange capacity today, but one thing that it relates to that and the overall charge on the soil. So clay is obviously, if you have more clay in your soil, the soil is going to be harder to till. And then if you till it when it's too wet, you're going to start pulling up larger clods and something. So just make sure that you're waiting on, until they're thoroughly dried out enough to till if you're going to be doing that. Next slide. Looking at soil structure, you've got granular, which is typically up here in the left-hand side. That's in your A horizon, so that's really great for root growth. If you start looking in the B horizon, you're going to start getting into your blocky, your subangular or your angular blocky. And that's just basically where you're getting those particles starting to clump together. If you have a B horizon with a significant amount of clay and you drive tractors or roll your lawns or anything like that, drive trucks on it, you could potentially start seeing platy material, and it's where those materials get really compacted together. And so that really starts to limit roots penetrating through the soil and then also water movement through the soil. Prismatic, you can see the B horizon. There, you can also see longer freeze thawing cracks that show up on those. And those are also harder for roots, but when those cracks start to show up in the soil, the roots can actually move through the soil. That also helps with water movement as well. For columnar, also another thing that looks very similar, but the tops are just rounded, and similar principles to the last structure there. The next thing I want to talk about here is soil color and drainage, and I'm briefly going to talk about this. Drainage is basically relating back to how well that water is going to be moving through your soil. There's poor drainage, well drained. You obviously want to have somewhere, with a well-drained soil, but not too much of a well-drained, because you want to be able to hold on to water over time. So looking at this slide here, the main difference that you can see from all of this stuff is soil color. So you get organic matter, darker content, lower profiles, and you can see organic matter accumulation. So waters run off and push the water through that, or the organic matter down into that lower topography. And that's something that you can see from that there. Let's go ahead and go forth. Soil color and drainage. So if you have iron that's oxidized, it's been Fe3+, you get your red, orange, and browns, and you get reduced colors. So if it's underwater, it starts turning gray. Organic matter is a brown or a blackish color. And so those are some of the different things that you can see with soil colors there. We also utilize the Munsell soil color chart to determine soil colors, but make sure that you wet the soil before doing that, so you get the true color of that soil profile. And if you guys are interested, you can follow up with this type of stuff in the Master Gardener class if you choose to do so. So taking your iron, so the left profile there, you can see it's dry and well drained. And so you got your red, yellow, brown, and orange. And then on the right side, you start getting into your grays and blacks, and you start seeing that modeling. So go ahead and move on to the next slide here, Amanda. You see modeling where you get gray spots next to reddish or brown spots. And so that's where it's telling you that the soil profile is not fully drained or fully wet throughout the entire year. So you'll see that there's times where that fluctuates when you get more rain, less rain, and based on that, you can determine where that water line is throughout the year. So move on to the next slide here. So wet soils, we've already talked about, they have little oxygen. If you start having issues with that, plants can get wet feet, and then roots can die when you have issues with that. Also, depending on what types of plants you have or how the soil is, it just kind of depends on, we refer to that as the right place, right plant, and making sure that the soil properties are right to make sure you're watering properly. So if you see here on the left-hand side on this graph here with the hose, the water, the sandier soils on the left, you see how fast the water moves through that. But with the clay content here on the right side, you get kind of these wetting fronts that kind of spread out laterally. So across the horizontal, and they don't go as deep as quick. So heavier clay soils can be watered more slowly, and sandy soils have to be watered more frequently because the water just moves through so quickly. So we know based on that, the more extreme would be the left-hand side where you have drought issues, and the right one would be more drought tolerant. All right, so let's go ahead and move on, Amanda.
All right, thank you, Austin. So yeah, as you said, I'm Amanda Baird. I'm the other Ag and Natural Resources educator here in Tipton County. And as Austin was telling us about all of these properties that we can commonly find in soil, one really good resource that I hope you all might know about is the Web Soil Survey. And now this is what the soil survey looks like on the home page. We're actually going to explore this page really quickly here. So I have this pulled up, and you were emailed a resource guide, and in that resource guide, it has the link to this. When you get to the home page, you can just click the big green button, start a new session. It comes up here. Now, as this is loading, one note is the address here. You can come in and you can actually enter in your own address. For this purposes, I'm going to put in the Tipton County Extension Office. And then you can zoom in. And once the map has loaded, you'll notice up here at the top, it's called an AOI, or an area of interest. I will quickly form one of these so you can see this. As we are creating this area of interest, what it will do is it will now pop up and create a soil map for us. And from this soil map, you can actually find a lot of the properties such as the texture and the structure. And now that I have defined this area, we can go up here at the top, and there's so many ways to explore it. We don't have time today to explore all of them, but I would recommend that you use this tool at home and you pull up your own soil maps for your house. So just as an example here, we have our patent soil, about 94%, and right there we see a silty clay loam at the 0 to 2%. We can even click in on here and it'll show us even further details. So make sure, and here is just all the properties. So, you know, those soil horizons that we just learned about, the textures here, the drainage, it's poorly drained. This gives you so much information. Now, linking back to the PowerPoint. Alrighty. But as we move forward, once we have all that information about the soil, another thing that's going to be really important for our plants and plant growth, it's going to be looking at those soil chemical properties. Now, plant nutrition is often confused with plant food and with fertilization, but we know that plants make their own food through photosynthesis, and plant nutrition is going to refer to a plant's need for and use of basic chemical elements which are required for that plant to complete their life cycle, or that plant to then produce seed. We can see here from this chart, it is showing you the essential nutrients that plants would need. Now, we have the three elements of carbon, oxygen, and hydrogen, and those are, of course, supplied by water and air, but the other essential elements are going to be supplied by the soil, or potentially if we had a deficient soil, we would then add those in. We have these different plant nutrients here as the macronutrients or micronutrients. And these are critical to the normal plant growth and development, but they're just needed in different quantities, right? So a plant is going to need more nitrogen, phosphorus, potassium. That's why it's a macronutrient compared to the micronutrients such as iron, but they're both equally important. When you're looking at your soil, one thing that will be important to note and to know is going to be your soil pH. Now, soil pH is just a number that indicates if your soil is acidic or if it's alkaline. Most soils have a pH of between 5 to 9, but a soil with a 5 pH, now that would be very acidic. So if we see this graph here, we can see Slightly acidic here at the 5 to 6, with 7 being our neutral. And then we also can see that anything 7 and above is going to be very basic. Most of the Indiana soils, I will tell you, we tend to have more basic soils, and many of our native plants in the Midwest actually grow well in those basic soils. But this is where, as gardeners, we can run into issues. So if we are wanting to grow blueberries or azaleas, we know that those like more of an acidic soil. And if you have a basic soil, you might have to do things to adjust that soil pH. This could be by adding sulfur or other different acidic fertilizers. And one of the issues with blueberry production, sometimes you won't even get the fruit if your pH is not right. Now, as an extension educator, we often get asked the question about what's the difference between an organic or a synthetic fertilizer? And really, it's just the materials in a sense that they're made from. So when we're looking at our organic fertilizers, we can see that these materials are mainly derived from plants or animals, and there are usually more of a slow release nutrient. So we have to have those microorganisms in the soil to help us break down that fertilizer so then a plant can actually use it. Now, synthetic fertilizers, in most cases, those have been manufactured to be a material that the plant is already able to uptake. You'll notice with a lot of the organic fertilizers as well, if you go to any store and purchase one, they have lower percentages of nutrients in them. And what that means is, if we look here at this graph, so imagine that this is a bag of fertilizer. Every bag of fertilizer is labeled with 3 numbers. So here we can see that we have our 16, 4, 8. That is the guaranteed analysis of the percentages of nutrients that's going to be in this bag. Now the 16 is going to be our nitrogen, then our 4% is going to be our phosphate or our phosphorus, and 8% is going to be that potassium. So just think of this as NPK. And it's really important to be able to look at this our fertilizer bags and to know what's inside of them. So that's why it's important to know that it's NPK. Because if we take a soil test, then we'll be able to see if something is very high. If we already have high phosphorus in our soil, maybe we would just apply nitrogen and not phosphorus that following year. Now, soil testing. Soil testing is extremely important. We always say that this helps us as the home gardener know how to have the right nutrients and to keep our gardens looking the way that we want them to and our plants healthy. However, the results and recommendations of a soil test are only as good as the sample that you submit. And if you are collecting a poorly collected sample, you could actually get some misleading results. We typically do recommend a soil test every 3 to 5 years. And you can take the soil test at any time, but if you're going to do this for your garden, it would be important to take that soil test before planting, so either early spring or late fall, so that if you have some nutrient deficiencies, you are able to adjust for that. Now, for example, let's look at if we were going to take a soil sample in our garden. We would need to have a clean container, so a bucket. We can also have a soil probe, and in most cases, you should look to your extension office. Sometimes they do have soil probes that you can borrow, but if you don't have a soil probe, you can just use a shovel. So we would take our sample core, so we would take our sample in our garden at a depth of about 6 inches. And when we're using our garden, we would go in a zigzag or even an M shape, and we take about 10 to 15 of these sample cores. When we take this sample core, we then put it in our bucket. We'll mix that all around. We would remove any of the debris we had. We'd allow it to air dry. Then we take about 2 cups of that soil, and we can put it in our sample bag. and we can fill that out, the information that would be required from the lab. So for example, they might ask you what you plan to plant. So this case, we'd be planting a vegetable garden, and you can also then tell them, you know, if you're going to do your front yard or backyard, your lawn, the sample depth would be different. So for lawns, it's at about 3 inches, whereas pasture, it'd be about 4 inches. And then for our gardens, it's 6 inches. Now these soil samples, they'll tell you the organic matter you have in, they'll also tell you nutrients such as phosphorus, potassium, and they'll also tell you the soil pH. So all of these things we're talking about here, you'll have and you'll know. This is a list of the soil testing labs that we have throughout the state. And you can also contact your local extension office just in case there are other recommendations for your county. I always like to tell homeowners that when you're looking at the different soil testing labs, you can always go to their websites and look at the way that they give you the report back. So you have to know how to read the report. And at the extension office, we're more than able to help you do that and read that report. But for example, if you go to ANL Great Lakes, because they're the first one, they'll have examples of what their reports look like. And so you want it to be easy for you as a homeowner to read, because if you have that sample test, but you don't know how to read it, then it won't be as easy for you to implement something such as adding a fertilizer.
All right. Thanks, Amanda. My name is Krista Poland. I am the Ag Educator in Cass County, and I'm going to talk a little bit about supplemental lighting. So supplemental lighting is something that can be challenging for home gardeners when starting their seed indoors. So a lot of the process is many steps, but the inadequate light is really what sometimes inhibits people's experience when they plant those seeds indoors. So unfortunately, we can't just match the light intensity of the sun, and whether we put those plants under a grow light or in a bright window, and this time of year, we can't mimic the sun, but we do the best we can with alternative lighting. So when we finally can transplant outside, sometimes we'll have those leggy, floppy plants. And the term leggy is a horticulture term. And that's the term we use when we have those plants that are really long. They have those long stems. They're very weak. If a little wind hits them in the hardening process, they'll quickly get tangled with other plants that are near them, or just blow completely over. And that happens due to the absence of or the low intensity of light. So we really want those shorter, stockier plants that will end up being healthier and stronger plants when transferring to the garden. So we're really talking about those those thick stems that you see when you go to garden centers or nurseries. That's what we're aiming for when we're starting seeds inside. And this supplemental lighting will help us achieve that. So in general, in order to have good seed starting light, you need to provide both red and blue light. So some bulbs are cool colored blue, while others are considered warm colored, and those are called red bulbs. So using both bulbs offers a broader spectrum of light, and that's what we're hoping to achieve when we're talking lighting for plants. And then they do have a specific light called a grow light now that is out there, and those are specifically made for plants. But there's a number of other types of bulbs that we can use that are available that work well on plants too. Another thing we want to consider is automatic timers. So those are nice to use with supplemental lighting because we're going to use this lighting a lot longer than we would for the typical daylight, because once again, we aren't the sun. We're just trying to provide that supplemental light. So a general rule is that seedlings need between 16 and 18 hours of supplemental light per day. So those timers are going to really help us control that. So we're going to talk about the types of bulbs that are available in addition to those grow light bulbs that we discussed. So the incandescent lights, those deliver the mostly red rays, but they have a little blue, which is needed to produce a plant's energy. Now, this makes it kind of probably one of the poorer choices for your grow light system. These lights produce a lot of heat, and that heat can end up burning your plants if they're too close. So if they must be used, it's important to just keep those lights at a good distance from the plants, and that will reduce the amount of, unfortunately, that does reduce the amount of light that your plants are going to get as well. So you can't keep them too close, but then when you pull them away like they need to be so the heat doesn't damage them, they're not getting the light they need. So that's kind of why we kind of steer away from those, but they will work if that's all you have. The next type we're going to talk about is the cool white fluorescent light. And so this type of light delivers a small amount of red rays in addition to orange, yellow, green, blue rays, and it's a better choice for indoor lighting systems. So the fluorescent bulbs are used especially in combination with a special fluorescent plant growing light, and they're used because they provide that distribution of red and blue rays. So they can make your growing system a lot more efficient. Now, it is recommended that if you use this type of light, use one plant growing bulb to 1 or 2 cool white bulbs. So kind of a combination there is what we're talking about. The fluorescent bulbs are not only 3 times, they're not only 3 times more efficient than an incandescent bulb, but they also provide about 10,000 hours or more of light versus the 1,000 hours that the incandescent bulb provides. Those tubes also give off little heat, and they can be placed approximately 2 inches above the plants. And so that allows for that thicker stem to grow instead of getting those leggier plants that can be very hard to work with when we're positioning those lights away. So the last type of light I want to talk about is the LED light. And that's the one that's probably newer to the market, it's newest to the market. And those LED plant grow lights have been researched by NASA for over a decade now, and now they're out in stores, and they've been out in stores for quite a while. So they produce little heat, they consume very little power, they are long lifespan. They produce the light wavelengths that plants thrive in. So in many studies, many plants did better and they grew taller in less time using the LED lights. So for a lot of people who are going out and willing to spend a little extra money, this is the choice that they're going to make if they don't make the grow light choice. So they're not necessarily the best option for small home gardeners because they can be pretty expensive. But larger home gardeners or people doing it to sell produce will tend to pick those. I also want to provide a chart. This is a comparison chart, and it kind of makes it easier to compare the different types of bulbs that are popular to use when doing your indoor lighting system. And when you're looking at that, costs can come into play, different priorities for different people. So some people are concerned with the energy efficiency and different things like that. So this chart really helps kind of narrow down and help you make your choice. And so the last thing I want to show you today is there's a number of different types of lighting stands you can use. And, you know, right now we're in a time where we're kind of all in our homes, not going very many places. And I want to show that taking a simple shop light that you have will work. You can also take an old rack, a storage rack that you have that you might have put canned goods or something on at one point. Maybe you're not using it anymore. You can use that. The one thing I will suggest is that you make sure you have that light in place before you start putting your plants on the rack, because sometimes that can get awkward. You can end up spilling a tray and just making kind of a mess, and it can be frustrating if you're trying to add that light later. So put the light in there before you put the plants on there. So there's a number of different systems. You know, you can look all over the internet and find all kinds of DIY methods to creating those plant stands. But once again, a lot of those shop lights or things that you might have around the house can work. And you can simply switch out some of those bulbs and make those work for now. So that's going to wrap up today's session. Were there some questions that we needed to answer, Corey?
So I had one from Kurt Campbell. He asked, how do we feel, or what about soil test kits at home? I didn't know if Austin or Amanda would like to touch on that.
Yeah, so there are some off-the-shelf soil test kits that you can grab at like a hardware store or a garden center. So you can pick up some of those. They do have the ability to test for soil pH, nitrogen, phosphorus, and potassium, but it's not going to be that research or commercial laboratory grade results that you're going to be getting from, say, one of those soil labs that you get on there. So, I mean, if you're just wanting like a quick and dirty measurements of what you think you have in your soils, that's something that that you can go and grab with that. All these test kits will likely have instructions with them, so just make sure you follow instructions that do have that or have them with that. We have any other
we had another one, Krista. Maybe you could answer this one. Janet would like to know how close plants should be to lights when seeds.
So it's going to depend on the light. Some of them are 6 inches. Some of those are a little higher. We can add that in one of the resources too. So it depends. It depends on the bulb. If you start noticing wilting of the plant, you are definitely too close. And you're probably better off to start a little higher than too low.
Another question rolled in about if we will be sharing the presentation materials with the participants via email. We can definitely do that. We will have those. This recording or this presentation is being recorded, and I believe we'll be putting those on YouTube, but we can definitely work on sending them out in email as well. I have another question. Maybe Amanda, you could take this one. Lindsay would like to know, how does the web soil survey know soil details? When were they measured? If she's been amending soil for 10 years with compost, is the web soil survey likely to be accurate?
Yeah, so the web soil survey, it came from data through soil scientists, through the USDA, as well as the Natural Resources Conservation Service, or NRCS, that you might have heard of. And they've worked with that partnership as well as Extension. Most of that data, Austin or Krista, you can jump in, I want to say was originally around the 70s. Don't quote me too much on that. But the thing about soils, and as we're even learning with Austin, is if you've been amending your soils for 10 years, you know, the top, maybe if you're amending down 4 inches or 6 inches, that might be different than what the soil survey would say as far as your organic matter content. But the rest of your soil does not change that quickly. As we even learned with Austin and what he was saying, you know, it can take up to 500 years for 1 inch of soil to develop. So the other principles on your soil is likely, it's going to be truthful on what it is. The only other issue sometimes you run into with the web soil survey is if you're in a newer development. So if your house was just built, a lot of the times, unfortunately, homeowners do take that subsoil that we just learned about, heavy and clay, kind of flip that over, and now that is your topsoil. In your case, I definitely would say that you should at least take a soil sample so you can see actually and compare your improvements on what you're doing to the soil.
One of those, to expand upon that, the soil, if you do like through a commercial soil lab, you're going to be getting information on your organic matter content. So if you looked at that versus the web soil survey, I can't remember if the organic matter content is in there or not, but I would say that you would be able to determine what improvements or what organic matter content would be from that soil. So make sure you take a look at that. All right,
think
well, Corey?
That's the questions that I had in the chat box right now, unless anybody else had any other questions.
All right. Well, we appreciate everybody's time. We got another one in the chat box here. All right. So regarding the soil survey, can you please go over again what this helps with? Should my yard be tabular and spatial? I don't know what this means. Keeps dropping down here. Okay, so the web soil survey is good to help you with understanding like what the preliminary soil is. So you can get what a typical soil profile looks like in there. You can find out what the drainage classification would be for that. So we really wish that we could go through like a whole in-depth class on the web soil survey. But you can see what soil profiles look like, organic matter content, you know, what types of classifications you can utilize that soil for. More or less, I mean, what you can utilize that for is just to look at to see, you know, your soil does vary on your property. It's not the same in one spot versus the other. And then you also might have different drainage parameters based on those different soil series. So that's something to take a look at. But, you know, just because you have soil that's right next to each other does not mean that they are the same soil. So they're all a little different. I'm hoping that I addressed that question, but Karen, if you want, you can email any one of us. I'm going to go ahead and type my email in the chat box. It's pearsona@purdue.edu, and I can connect with you and try to answer that question on there as quickly as I can. I appreciate you all, and
hey, Austin, there's a couple more.
Okay.
So Valerie wants to know, to amend former cornfields for a vegetable garden, could you recommend best cover crops requiring limited specialized tools?
If you're just wanting to go in and increase organic matter, it just kind of depends on what you're trying to do. So I don't necessarily have a recommended tool, but I would recommend first and foremost that, you know, cover crops can be difficult to manage. So making sure you start off with something that's a little bit easier that would winter kill or something like that. So your oats and radishes, those will all winter kill for you. So you go through and start applying those in the fall. And then let them grow through the fall, and then they'll actually die off for you. Some other ones, if you start utilizing different cover crops, like the rye or anything like that, you're gonna have to start doing either some type of mechanical termination, or also another way that you could go, you could have to terminate with some type of pesticide. But Kirk Campbell, the former educator in Wabash County, has mentioned that oats are good as cover crop. But the nice thing too is that there has been some data with that it helps with weed suppression. And so that's something that you can do, but we could do an entire class on this as well. But we didn't select it for this series. So you'll be getting a survey. Please fill that out and make sure that you put in what type of topics that you would like to see, maybe for other monthly webinars that we like to do in the future. So thank you all again, and have a great weekend.
Hey, Austin.
Yep.
Sorry, there's another one. Karen would like to know, how do you find the soil info on the soil survey?
Yeah,
Okay.
you can see my screen here. So remember, we went to the soil survey, we pressed the large green button. We then went over to our area of interest. I already have mine defined, so I picked the Purdue Extension Office in Tipton County. Now that I have this, there's a bunch of tabs here at the top. There's so much information you can go over, but for basic information, click on soil map. It then is now showing me I have two different soils here. I have the Delray as well as the Patton. If I wanted to even learn more information other than what it says right here, I click on it and it gives me lists and lists of the common settings as well as properties and qualities of the Patton soil. So I can see that it's poorly drained. I can see the slope here. It's not very prone to flooding, but there is some ponding there that happens. And you can get the printable version. You can also go to download soils data, and you can go to the Soil Data Explorer, which is probably best for homeowners. If you go to the Soil Data Explorer, you can go over to even Intro to Soils and look at some information, click there. Suitabilities, if you're ever thinking about maybe building a house on a piece of land, you can actually go to building site development too and look at, is this going to be good with a basement? So dwellings with basements. I mean, there's so many, so much information here that, yeah, we wish we could go over all of it, but that is how you get the basics there.
All right, it looks like the chat box has calmed down now. I think we're ready to call it a weekend here. So thank you all, not meaning that we're all gonna go start our weekends now. We still have time to work, but you all have a great weekend and let us know if you have any questions. Thank you for participating today.